So let us try to prove the oscillation lemma in the case where we have a harmonic function at hand. So I recall that we have assumed, without loss of generality, that u is bounded by 1 in absolute value, and that it's going to be negative half of the time in this measure theoretic sense. And we want to prove that in this case, the maximum of u is going to be less than 1 minus theta in the ball of radius 1/2, from which we'll have that the oscillation has decreased. All right, so how do we do this? So take a point x in a ball of size delta centered at the origin, where we're going to fix delta small, and then apply the mean value formula as usual. So we have that u of x is equal to its average on the ball of size of radius 1 minus delta centered at x of itself. And so this whole thing is bounded above by the measure of a ball of size 1 minus delta times the integral of u plus on the whole ball of size 1. All right? And now since we know that u plus vanishes at least half of the time, this means that this integral, and since u plus is bounded by 1 obviously, is going to be less than 1/2 of the measure of b1 divided by the measure of b1/2, right? Of b1 minus delta, sorry. b1 minus delta. Okay, so if we take delta sufficiently small, depending on dimension only, we can make sure that this whole quantity is less than 3/4 for delta positive small. Okay, so already for those points in the ball b delta, we're done because we've decreased the maximum of u. Okay, so now we have to take care of the other points. So let's say this is our smaller ball b delta, and now we're going to take a point x in the ball of size 1/2, and we're going to take so for x in the ball of size 1/2, we're going to use again the mean value formula. So this time we can do this on the ball of size 1/2 only. As u is harmonic in b1. So here's the ball centered at x on which we're going to look at the average. And so this quantity is going to be less than 1 over the measure of the ball of size 1/2 times what? So let's see. In the ball of size 1/2, there's a piece already where we are inside the ball b delta that we talked about, and in that set, u is less than u plus is less than 3/4, so we'll get 3/4 times the intersection of b1/2 centered at x and b delta centered at 0, and in the complement of this set, the only thing that we know is that u is bounded above by 1. So we'll have here b1/2 of x minus b delta as the remaining piece. So now if we set 5x to be equal to the ratio of the piece of the ball centered at x of standard 1/2 that is contained in b delta to b1/2. What have we done? We have proved that for x in b1/2, u of x is less than what? Than 3/4 of phi plus the complement of phi times 1. So this quantity is equal to 1 minus 1/4 of phi. So now you see we have this function phi of x, which is clearly continuous and defined in a compact set, which is the closure of b1/2. So phi is going to be bounded below by some constant. You can even feel it from the picture, by some universal constant depending on dimension only again. And so we have finally that u of x is less than 1 minus 1/4 of c, and this is precisely our 1 minus theta in b1/2.